also trade and take, and if takes, I take. If takes, queen e2, queen h4, g3, knight g3, check.
First of all, this isn't a tutorial. It's more of a small exploration into chess programming. In the past few years, chess has become increasingly popular, even though the game itself can be traced back more than 1,500 years. Personally, I started following chess on YouTube a few years ago. I enjoyed watching some of the tournaments that were streamed online. Despite that, I never really felt the urge to learn how to play chess properly. With this project, that might finally change. Where did the idea come from? The goal was to make a small handheld gaming console, on which the player could play chess against the computer. The console would be based on the ESP32 microcontroller, which is extremely advanced for its size and price. However, compared to a desktop computer, it's quite limited. Because of that, I'd have to be careful about the program size. The controls would also be a challenge, since the display isn't a touchscreen. Moves would need to be entered using buttons. To make this work, I had to code chess as a game with all its rules and also somehow integrate a chess engine into it so that players could compete against a computer. Now, I'll tell you how I coded a two-player chess game. ChatGPT. There it is, I said it. I typed it into ChatGPT, asking it to code chess in the Python programming language. With very little hope, I waited for it to generate the code. When it finished, I simply copied and pasted the code into a Python interpreter, and it worked. Of course, the board was drawn using keyboard symbols, the pieces were represented by letters, and moves were entered using coordinates. For anyone with experience in game development, you know this is actually the harder part. The next step, adding some kind of graphical interface, is the easier part. This wouldn't be much of a story if I didn't at least explain a bit about how chess programming works, at least conceptually. The way I approached programming chess is similar to how I program tic-tac-toe, though tic-tac-toe is much simpler. That's why it's an excellent exercise before tackling chess. In tic-tac-toe, I represented the board as a two-dimensional array, just like in chess. Each player can place their mark, X or O, depending on whose turn it is. There's a section of code that tracks which player is currently moving. If a cell is already taken, no new mark can be placed there. At the end, the winner is determined by checking whether three X's or O's are aligned. The entire thing fits into about 100 lines of code. In this case, I used the Lua programming language, which is very simple, even simpler than Python. It also happened to be the last language I'd coded in before starting this project. I approached chess in a similar way. The board is represented as a two-dimensional 8x8 array. The x-axis, instead of numbers, is represented by letters A through H. At the start, the pieces are set up properly on both sides. Uppercase letters represent the white pieces, and lowercase letters represent the black ones. Tracking whose turn it is can be done very simply. White always moves first, which means if the total number of moves is odd, it's white's turn. If it's even, it's black's. Next comes programming the pieces. Each piece has its own unique movement rules. Pawns can only move forward one square, except from their starting position, where they can move 2 squares forward. Of course, a pawn can only move if the square in front of it is empty. In my code, that just means checking if there's a dot in front of it, indicating an empty space. And that's where my practical knowledge stopped. I didn't bother writing the rest of the code for the other pieces, since I had already generated the code that worked. If anyone wants to try the chess game ChatGPT coded, the code will be in the video description. Just copy the whole thing, Google online Python interpreter, paste it, and press run. Now for the chess engine part. Some of the most famous chess engines are Stockfish, Komodo, and Fritz. What exactly happens inside of them, I couldn't tell you, but I do know where to find answers, or at least something close. There are several great YouTube videos explaining how a chess engine works. The first one is The Fascinating Programming of a Chess Engine by Bartek Spitzer, which explains board representation, board evaluation, and the Minimax algorithm in just a few minutes. There's also I Coded a Chess Engine in 7 languages to test performance by Coding with Tom, which does exactly what the title says. He coded a chess engine in several popular programming languages and compared their performance. There's a whole community of people dedicated to studying and improving chess engines. The main website where everything related to chess programming is documented is chessprogramming.org. They even have a Getting Started section that explains how someone can begin programming a chess engine, including the board representation, search, and evaluation methods. Inside a chess engine, it's important to minimize the amount of code so that the computer can calculate moves faster. And for that reason, instead of using a two-dimensional array for the board, many engines use a single 64-element array, which is a bit more complex to program, but easier for the computer to process. Then, there's the evaluation algorithm, which determines the position's strength. You can actually see these evaluations live during online chess tournaments, usually displayed as a vertical bar that shifts up or down depending on a player's advantage. Over the years, many smart people have contributed complex algorithms to improve chess programming. Unfortunately, I haven't had the chance to study those algorithms, and honestly, even if I did, I doubt I'd understand them. So instead, I'll explain how I integrated a chess engine into my project. My project includes an ESP32 development board and a 4.2-inch e-paper display. Although the ESP32 is an incredibly capable microcontroller for its price and size, it's still limited in computing power. Because of that, the chess engine I integrated had to be compact compared to the ones used on computers. Luckily, there's actually a perfect engine for that, the MCU Max. MCU Max is an optimized version of the Micromax chess engine. The best part is that it's made up of just 2 files and around 1,000 lines of code in total. These files can easily be integrated into an existing chess game to serve as the AI opponent. After that, I just needed to implement graphical display for the board and pieces, and replace the keyboard input with physical buttons. 8 for columns, A through H, and 8 for rows, 1 through 8. That's 16 buttons total, which is more than the available ports on my ESP32 controller. The solution was a button matrix, a technique that allows connecting 16 buttons using only 8 ports. The same principle used in wiring keyboard buttons. Now, why did I describe all of this? Using generated code isn't a bad thing. For prototyping, it's actually an excellent tool. Of course, it's important to understand what the code does when you look at it. For example, if you just want to test an idea you're unsure about and don't want to waste too much time, this approach saves time that can be better spent elsewhere. If the idea works out, and you understand what the code is doing, you can always go through it later and modify it as needed. People often compare AI to a calculator. Just another tool that can help us and save us time. As for chess, it's a great game. Trying to program it yourself isn't that hard. The real challenge is making your code as small and efficient as possible, just like in professional chess engines. Whether you want to write your own code or use someone else's, just don't be afraid to experiment with different methods and tools. That's it. Thanks for listening.